In this lesson, I'm going to remind you of 4 methods for solving quadratic equations that you need to know. So if you look on Schoology, there are 4 methods that I've reminded you of and given you hints on when they are best to use. And I'm going to illustrate this through some examples. Just want to remind you of the relationship between a function and an equation. So on the left I have a function, it's in 2 variables. You know that it makes a parabola. This one would cross, they have a vertex at -4 or 0, -4. It's going to have 2 x-intercepts, and I know they're going to be at 2 and -2. And how do I know that? Because I know the direct tie to a function versus solving an equation that's very similar. If I asked you to find the x-intercepts, well, that's where I let y be 0. Okay, so if I plug in 0 right here, I can solve this several ways. I can do it by factoring. So factor into x plus 2 and x minus 2. Okay, and then I apply the zero product property that says x plus 2 equals 0, or x minus 2 equals 0. And solve each of those, I get x equals -2 or x equals +2. So the solutions to this equation are identical to the zeros or the roots on this function. Right, so we've looked at graphing in 3 forms: standard, vertex, and intercept. So if I ask you to find the x-intercepts for any function in these 3 forms, you're going to let y be 0. So let's look at what's a good method if your function is in standard form. So I am going to begin with this function by letting y be 0. So I have 0 equals x squared minus 9x plus 16. If it's in standard form, if I can factor it quickly, I'm going to go that route. But I don't know anything that multiplies to 16 and adds to -9, so my backup method that always works would be the quadratic formula. Until you have it memorized, it's great to write it several times. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. And then I substitute. Well, to do that, I'm going to identify a, b, and c over here. 1, -9, and +16, and then I'm going to substitute. So I plug in 9 for -b. Then b squared is -9 squared minus 4 times 1 times 16 all over 2 times 1. So when I calculate this, I start by figuring out the value of just the radicand, meaning what's under the square root sign, this part here, and that comes to 17. So I have 9 plus or minus root 17 over 2. Okay, these would be my 2 exact answers. One being 9 plus root 17 over 2 and the other 9 minus root 17 over 2. So these are exact. There's 2 of them. But you know, if you were graphing this, that might be hard to conceptualize where is that. So it's great to throw this in the graphing calculator to get your exact answers. Now when you type this in, just a reminder, it'd be 9 plus root 17 in parentheses divided by 2, or 9 minus root 17. Put the whole numerator in parentheses, divided by 2 to get those 2 decimal answers. So here are my 2 approximate answers. So I know this would be a parabola opening upward, and those are my 2 x-intercepts. So what if we have something in vertex form? My go-to method, again, first of all, would be I need to plug 0 in for y. And I then use the square root method. So I'm going to give you a reminder of that. So what I do is I am going to try to isolate x by undoing everything. Very algebraic. And what do I do here? I am going to add 11 to both sides, which gives me 11 equals 7 times the quantity of x minus 6 squared. I'm going to undo 7. Don't make the mistake of distributing. You can't do that. X minus 6 squared still over here, and I have this fraction, 11/7 on this side. Now to unsquare something, I take the square root. And here's something you need to remember, okay? The moment you take the square root, you need to put plus or minus in front of it because there are 2 roots for a square root. So now I have x minus 6 on the right, and I have the square root, or positive and negative, the square root of 11 over 7. And I'm going to actually rewrite that because I'm not allowed to have a square root down in the denominator. It's not considered simplified. So I'm going to rewrite that as the square root of 11 over the square root of 7 and dig back into your toolbox of how do you rationalize the denominator. Well, this is where you multiply by a disguised form of 1, root 7 over root 7. And what happens is we actually have plus or minus root 77. You multiply those two radicands together. In the denominator, you'd have root 49, which is just 7. And now I've fixed that problem. Over here, I still have x minus 6. So what I'm going to need to do here is, final step would be add 6 to both sides. And when I do that, I have two answers here, 6 plus root 77 over 7, and the other one would be 6 minus root 77 over 7. So two solutions, and again, I'm going to find my decimal approximation by putting that in the calculator. So here are my two approximate answers, but leaving it as exact answers is great practice. So I actually already did one problem showing you by factoring in the zero product property. But what I want to point out here is, so if you already have one that's in intercept form, your function is actually already factored. So to find your x-intercepts, again, you let y be 0. And I'll just recopy this part. And what you're going to do is you're going to apply the zero product property, which is where you take each factor and you set it equal to 0. So the first one, if I wrote 0 equals 2, well, that's not true. Okay, so it's just a coefficient, a plain old number. It's never going to give you an answer. But my other one, x minus 4 equals 0, or x plus 5 equals 0, gives me two solutions, x equals 4 or x equals negative 5. So for this quadratic equation, notice it's an equation, not a function. If I were solving this one, I would do it by factoring. Factors would be x minus 2 and x minus 3, and then the zero product property would give me x equals positive 2 or 3. Now let me show you on a graphing calculator. On a graphing calculator, to solve a quadratic equation, you're going to type it in as if it's a function, hitting y equals, you type your function in and tap graph. There's my parabola. To find the zeros of the function, it's hidden under second trace, and it's option 2. For zeros. You're going to move your cursor so it's slightly to the left of where it crosses the x-axis. So it's going to say left bound. If you see that at the top of your screen, you hit enter, you move it to the right of where it crosses, and I hit enter. And on your screen, you can see the zeros. Now I do need to tell you, with the actual TI 84 graphing calculator, you have to hit it a third time. It'll say guess, and then it's going to tell you the zero. All right, so this is telling me that I have a 0 at 2, okay? And I need to find my other 0, so I'm going to do second trace again, option 2 for zeros, and I'm going to move it. This time when I'm to the left, I'm underneath the x-axis. I hit enter, move it so it's above, hit enter again, and there it is. My other 0 is 3. So 2 and 3 are my two zeros. I hope this video helps. If you still have questions, don't forget to reach out.